This is section 10.1, part D, Inference for experiments. Most of the experiments in this chapter have involved data that were produced by random sampling. However, many important statistical results come from randomized comparative experiments. Here is one such experiment that compares two proportions. High levels of cholesterol in the blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol reduce heart attacks? The Helsinki Heart Study recruited middle-aged men with high cholesterol but no history of any other serious medical problems to investigate this question. The volunteer subjects were assigned at random to one of two treatments. 2,051 men took the drug gamfibrozole to reduce their cholesterol level. A control group of 2,030 men took a placebo. During the next 5 years, 56 men in the medication group and 84 men in the placebo group had heart attacks. Is there apparent benefit to the medicine statistically significant? Perform an appropriate test to find out. So first we're going to start with our state. Remember, in the state, we're going to give our two hypotheses. We're going to define the parameter. So we hope to show that the medication reduces heart attacks. So we have a one-sided alternative. Our null hypothesis is that P1 minus P2 equals 0, and our alternative hypothesis, this should be an H sub A, is that P1 minus P2 is less than 0, where P1 is the actual heart attack rate in middle-aged men, like the ones in the study who took the medication, and P2 is the actual heart attack rate for middle-aged men, like those who took the placebo. No significance level was specified, so we are going to give an alpha level of 0.01 to reduce the risk of making a type 1 error, which concludes that the medication reduces heart attack risk when it actually does not. Next, we're going to come up with our plan. In the plan, this is when you state what method you're going to use and you check your conditions. So if the conditions are met, we are going to do a two-sample z-test for P1 minus P2. Now, the first condition we have to check is random. The data come from two groups in a randomized experiment. We need to check to see if they're normal. So we need to check to make sure, because we're talking about a probability. So we need to check the number of successes and number of failures for each group and make sure all of those are at least 10. Now, to do this, we're going to do this the number of the sample size times the probability of success, and we're going to do the sample size times the probability of failure. Or we can just do the total sample size minus how many successes there were, and that'll tell you how many failures you have. And since all of these numbers are at least 10, the normal condition has been met. Next, we need to check for independence. Due to the random assignment, these two groups of men can be viewed as independent. Individual observations in each group should also be independent. Knowing whether one subject has a heart attack does not give any information about whether another subject does, so these are independent. Next, you're going to do the do part of our process. This is where we're going to do our calculations. So we're going to start. We know that our sample size for group 1 is 2,051. We know our p hat 1, so it's for group 1. 56 of them had heart attacks out of the 2,051, or about 2.7% of them. We know group 2 has 2,030 people, and we know p hat 2, 84 out of the 2,030 had heart attacks, which is about 4.1%. The pooled proportion of students who did not, the pooled proportion can be found. So this is a typo. This is not about the students who did not eat breakfast. These are about the two groups of men. So our pooled proportion is going to be our x1 plus our x2 over n1 plus n2, or 56 people in the first group had heart attacks, 84 people in the second group had heart attacks, so 140 people total had heart attacks, over the two sample sizes added together is about 3.4% of them had heart attacks. Next, we're going to calculate our test statistic. This is when you do z is equal to p hat 1 minus p hat 2 minus 0, because our null hypothesis is that it is 0, all over the standard deviation of the pooled data. So it's going to be the pooled data probability of success times the probability of failure over the sample size for population 1, or sample size for population 1, plus the pooled data success rate times failure rate all over the sample size for population 2. And this is going to get us a z-score of negative 2.47. Now, once we have that z-value, we can look it up on our table, and we know the table is going to tell us the area to the left. So if I have a z of negative 2.47, the area to the left is what is given to us on the table. And that's going to be an area of 0.0068, which is going to be our p-value. So from this, we have to write our conclusion. So since our p-value of 0.0068 is less than the alpha level of 0.01, the results are statistically significant at the point alpha equals 0.01 level. So we can reject the null hypothesis and conclude that there is convincing evidence of a lower heart attack rate for middle-aged men like these who took the medication than for those who took only a placebo. The random assignment in the Helsinki Heart Study allowed researchers to draw a cause and effect conclusion. They could say that the medication reduced the rate of heart attacks for middle-aged men like those who took part in the experiment. Because the subjects were not randomly selected from a larger population, however, the researchers cannot generalize these findings in this study any further. No conclusions can be drawn about the effectiveness of the medication at preventing heart attacks for all middle-aged men, for older men, or for women. How much more effective is the medication than the placebo at reducing the rate of heart attacks? In the experiment, 4.1% of the men in the placebo group had a heart attack, while only 2.7% of the men who took the drug had the heart attack. A 95% confidence interval for the actual difference in the parameter can be shown below. So they took P1 or P hat 1 minus P hat 2 plus or minus the z star times the standard deviation. And they still did the standard deviation. With these ones, they did them separately. So this is going to be the probability of success times the probability of failure for the first one all over the sample size, and the same thing for the second. And this is going to give us a confidence interval of 0.0029 to 0.0253. So based on the results of this study, we are 95% confident that the medication reduced heart attack risk by 0.3 to 2.5 percentage points more than the placebo in middle-aged men like those in the Helsinki Heart Study. Again, we can only talk about those that are similar to the ones in the study because the people who were in the experiment were not randomly selected from the entire population, so you cannot generalize this to the entire population. Now, you can do some of this on your calculator. The TI-83 or 84 could be used to perform significance tests for comparing two proportions. Here we use the data from the Helsinki Heart Study to perform a test of the null hypothesis as P1 minus P2 equals 0. So to do this, you would press stat, you'd go over and choose test, and you're going to select option 6, which is a 2 proportion Z test. When the 2 proportion Z test screen appears, you're going to enter the data. Our X1 value was 56, and our sample size for population 1 was 2,051. X2 was 84, and the sample size was 2,030. And you need to specify that your alternative hypothesis is that P1 is less than P2, or in our case, it was P1 minus P2 is less than 0, but if you rearrange that, it would be P1 is less than P2. You can then select calculate and press enter, and it should run that test for you, and it will give you your p-value. So let's check our understanding. To study the long-term effects of preschool programs for poor children, researchers designed an experiment. They recruited 123 children who had never attended preschool from low-income families in Michigan. Researchers randomly assigned 62 of the children to attend preschool, paid for by the study budget, and the other 61 to serve as control group who would not go to preschool. One response variable of interest was the need for social services as adults. In the past 10 years, 38 of the children in the preschool group and 49 in the control group have needed social services. Does this study provide convincing evidence that the preschool reduced the later need for social services? Carry out an appropriate test to help answer this question. Once again, this is going to be a 4-step problem. Remember, in the state, you need to tell me the null and alternative hypotheses, you need to define the parameters, and you need to give an alpha level. So we want to perform a test at the alpha equals 0.05 significance level. The null hypothesis is that P1 minus P2 equals 0, so there's no difference, versus P1 minus P2 is greater than 0, where P1 is the actual proportion of children who did not attend preschool that use social services later, and P2 is the actual proportion of children who did attend preschool who use social services later. So we expect, our alternative says we expect that the children who did not go to preschool will need more social services than the ones who did go to preschool. Now for our plan, we're going to state what method we're going to use, and then we're going to check our conditions. So if the conditions are met, we will do a 2-sample z-test for P1 minus P2. Our first condition is random. The data comes from 2 groups in a randomized experiment, so we're good there. Next, we need to check the normal condition, which is the number of successes in this case would be that they used social services, and a failure is that they did not use social services in the 2 groups. So we're going to find the number of successes and the number of failures. It said that 49 people, or 49 of these children, eventually needed social services in the non-preschool group, and so the number of failures would be the sample size minus those who did, so there was 12 who did not. There were 38 students in the preschool group that needed social services and 24 who did not, so since all these values are at least 10, the normal condition has been met. Next, you need to check for independence. Due to the random assignment, these 2 groups of children can be viewed as independent. Also, knowing one child's need of social services gives no information about another child's need of social services. Next, we're going to do the do part of this. This is when we're going to do our actual calculations. So we know that N1 was 61. P hat 1 is going to be 49 out of the 61 needed social services, or about 80%. Group 2, the one who did go to preschool, there was 62 of those. And the probability of success, which in this case means they needed social services, there was 38 out of the 62 that needed social services, which is about 61%. The pooled proportion of students, in this case, again, this is still a typo, it's not about breakfast, this is who needed social services, could be found by doing x1 plus x2 all over n1 plus n2. So the number of people in the non-preschool group who needed social services plus the number of students in the preschool group who needed social services will be on top. On the bottom is just the 2 sample sizes added together, and that'll give you 87 out of 123, or out of all of those people together, all the pooled people together, about 70.7% of them would need social services in the future. Next, we're going to do our test statistic. So our z-value is going to be p hat 1 minus p hat 2 minus 0. Again, this is minus 0 because that's what our hypothesis was. So this is your statistic minus the parameter. And the parameter we got from the hypothesis, our null hypothesis, is that p1 minus p2 equals 0. If we do the actual p hat 1 minus p hat 2, we're going to subtract that from 0 over the standard deviation where we use our pooled statistic or pooled values. So we're going to do our probability of success for the pooled population is 0.7073 times probability of failure all over the sample size for population 1 plus probability of success times probability of failure for the pooled data all over the sample size for group 2. And that's going to give you a z-value of 2.32. Now from here, you're going to go to your table. Now we know that the z-value is 2.32. So our table is going to tell us the area that is to the left of this, but we want to find the probability that it is greater than that. So we are looking for the area to the right. So once you find the area on the table to the left, which is 0.9893, To find the area to the right of that, you would do 1 minus that area, and that's going to give us a tail on the right end of 0.0102. So since this is our p-value, we are now going to compare this to our alpha level to make our conclusion. And since the p-value is less than 0.05, we reject the null hypothesis and conclude that children like those in this study who have participated in preschool are less likely to use social services later in life. Now again, we just have to say those who are similar to the ones in the study. We cannot generalize this anymore because we didn't randomly select people from the entire population. We just randomly selected from a specific population, so we can only generalize to that specific group or children like those in that group. The mini-tab output below gives a 95% confidence interval for P1 minus P2. Interpret this interval in context, then explain what additional information the confidence interval provides. So our confidence interval is from 0.03 to 0.34. So this means we are 95% confident that the interval from 0.033 to 0.345 captures the true difference of non-preschool minus preschool and proportion of children who would need social services later in life. This suggests that between 3.3% and 34.7% more children who did not participate in preschool will need social services later in life than those who did participate in preschool. The interval gives us a range of plausible values rather than just making a decision about one specific value.